All right, well, let's just pick up right where we left off. We need to do a little grid here, and the left side needs to multiply to the left. So x times x will get me an x squared. I need to multiply the right side to get negative 12, so I'll do negative 6 and 2. So this diagonal is x times 2 is 2x. This diagonal is x times negative 6, that's a negative 6x. If I add those together, there's more negatives. There's 4 more negatives, so it's negative 4x. And is that my middle term? Close, but the sign is the wrong way. So if ever you do that, then you can just flip the symbols. So this negative 6, I'll flip it to a positive 6. This positive 2, I will now make it a negative. So this diagonal is a negative 2x. This diagonal is a positive 6x. If I have to add those, there's more positives. There's 4 more positives, so I get a 4x. And everything's preserved here. Like, the left side preserves to get x squared. Negative 2 times 6 still is negative 12. And my diagonals do multiply and then add to get positive 4. So I get x plus 6 and an x minus 2. That is now factored. So let's go on to the next one. X times x will get me an x squared. Ooh, negative 12 again. Oh no, it's close. I was gonna try looking at e here, and I think I know what to do now. So I'm gonna get I need negative 12, so I'm gonna do 4 and negative 3. It's actually completely backwards, or like the symbols are backwards from the one that's above. If you take a look, so negative 3 times 4 does preserve the right side, which is negative 12 if you multiply them. X times x is x squared, and my diagonals are a negative 3x and a positive 4x. And if you add those, you get a positive 1x, which is exactly what I have in the center. So I have this one, x plus 4, and then I have this one, which is x minus 3. I realize that this work here is extremely messy, and if I wasn't in such a panic to make these videos, I'm sure it would be nicer, but the notes that are online, the answer keys that are there, those are done in slightly nicer writing. So for what it's worth, you can check there. I. Okay, let's do I here. This is the first one that's different, finally. X to the 4. So this will be x2 times x2, because x squared times x squared, you can then add the exponents, you can get an x4, which is nice. I need to get 18. Okay, so that's going to be 6 and 3 or 9 and 2. So I'm just taking a look here. 6 and 3. So if you wrote down 6 and 3 and you wrote down 9 and 2, is there any way to get 7? Can you add or subtract 6 and 3 to get 7? Nope. Can you add or subtract 9 and 2 to get 7? Yep. So that's how I'm going to choose 9 and 2. So I'm going to choose 9 and 2. I have to make one of them negative. So I'll make that one negative. So this diagonal right here is going to be a 2x squared. And this diagonal is a negative 9x squared. There's more negatives, so my answer is negative 7x squared. That is not what I need. I need a positive 7x squared. So I got the number right, but the symbol wrong. So I'm going to make this negative 9 a positive 9, and the positive 2 a negative 2. So now I'm going to do my diagonals. I'm going to get a 9x squared and a negative 2x squared. And if I put those together and add them, I'm going to get a positive 7x squared, which is what I need. So I have an x, I can do this in green. I don't know why I just went there. So x squared plus 9. And then an x squared minus 2. There we go. This is now fully factored. The one thing that's different about this one is that it was an x4. But that was really easy to change. It was just an x2 and an x2. So for what it's worth, that's kind of as difficult as these things get here. Let's keep going. So I need an x6. Oh, wow. x3 and x3. If you multiply them, you get an x6. Now this is interesting. I need a 6 here. A positive 6. So I could do 6 and 1. But then my diagonals are going to be a 1x cubed and a 6x cubed. And if I add those, I get a 7x cubed, which is not what I want. I need a negative 5. So how about a 2 and a 3? That's the only other thing I can think of that multiplies to 6. So then I get 3x cubed and 2x cubed. If I add those, I get 5x cubed. And that's exactly what I need, except the symbol is wrong. So whenever you get the right number but the wrong symbol, you change the symbols. So this right here is a positive 2, so I'll make it a negative 2. And this one's a positive 3, so I'll make it a negative 3. And does that still preserve things? So the left x cubed times x cubed is indeed an x6. Negative 3 times negative 2, a negative times a negative still is a positive 6. And this diagonal is negative 3x cubed, and this diagonal is negative 2x cubed. And that gets me, if I add them, a negative 5x cubed, which is what I need. So I have that, and I have that. I've got an x cubed minus 2 and an x cubed minus 3. Those are that's my factored form. So I'm going to erase this stuff because this is getting a little extreme here. All this work. By the way, the diagonals, I'm writing them here because I'm talking. And I do not expect you to do them. I mean, you should be able to do this in your head. You're like, oh, negative 2 and negative 3, that adds up to negative 5. It should be pretty straightforward. You do not need to show me that work. All right, next one. Y's. Oh, great. So this is y and y, but it needs to be y4. So you can do y squared and y squared. Y squared times y squared is y to the 4th. And I need an 8. So an 8 I know is 4 and 2. 4 and 2 multiplies to 8. And I know my diagonals. It's going to be 2y squared and 4y squared, which gets me 6y squared, which is not what I need. See, 4y squared and 2y squared. It gets me 6y squared, but I need a negative 6. And so if that's the case, I can change the symbol. Instead of a positive 4, I'll do a minus 4. Instead of a positive 2, I'll do a minus 2. Now my diagonals are negative 4y squared and negative 2y squared, which add up to negative 6y squared. So hopefully you can see a hint here. Whenever you see a positive 8, or a positive number, but the inside is negative, that means that both of these have to be negative. Because negative 2 and negative 4 will still be a positive 8. So that's still preserved. The positive on the right-hand side is still preserved. And of course the y squared is still y to the 4. And the fact that they're both negative then allow me to add them and get a negative 6. So I've got a y squared minus 4 and a y squared minus 2. That is my answer. Okay, continuing on here. There and there. Y10. Okay, so I'll do y5, y5. And that gets me a y10. And I see, I'm like, okay, there's a 10 here, and it's positive, but this is negative. So the only way for me to get a positive is going to be, I don't know, 2 and 5 or 10 and 1. But it needs to be negative in the inside when I add my diagonals. So I'm going to make them both negative because that still preserves the positive right-hand side. So my diagonals here are negative 5, y to the 5, and negative 2, y to the 5, which add up to negative 7, y to the 5. That is indeed what I need. So I have y to the 5 minus 2 and y to the 5 minus 5. That is my answer. And that does work. Yep, so that's perfect. I'm going to try to write a little bit neater for what it's worth, which is nothing. There we go. Okay, so I got, what do I have? A few more to do. 3. Wow. Okay. What? This is only an x squared. So x and x. Negative 24. Okay. So I've done a ton of options. I got 12 and 2. What else do I have? 8 and 3, 6 and 4. Is there any of these that get me a 5 if you add or subtract them? It's like, no. Oh, that can get me a 5. So I'm going to choose 8 and 3. One of them has to be negative. So I'm going to make the top one negative for no other reason, but just to guess. And because I'm smart. So let's take a look at the diagonals. That diagonal is a negative 8x. This diagonal is a positive 3x. If I add them, I get negative 5x, which is what I need. So I have an x minus 8 and an x plus 3. There's no plus sign, obviously, but it is a positive 3. So that is fully factored. Okay, keep going here. X and x, 24. Okay, so that's 8 and 3. Oh, 24 or 24. 8 and 3, what is it? 12 and 2, 6 and 4. Is there any way that I can get 14? 6 and 4, yeah, 12 and 2. So I'm going to choose 12 and 2. It has to be positive, but the inside there, the diagonals have to be negative. So that's a sign to me that I'm going to make them both negative. So negative 2 times negative 12 still is positive 24. And x times x is x squared. My diagonals, negative 2x, negative 12x. You add them, you get negative 14x. So that's what I need. So there's my x minus 12 and x minus 2. Finally, the last one before we do this all over again on the second page. x3 and x3 get me an x6. 24 again. There's so many 24s. So 8 and 3, right? Get me 24. 6 and 4. 12 and 2. Is there any way to get 2? Yeah, with 6 and 4 gets me 2. So I'll do 6 and 4. And one of them has to be negative. So let's say I make the top negative. So this diagonal is negative 6x cubed. This diagonal is 4x cubed. That gets me, if I add them, a negative 2x cubed. That is not what I have. I have a positive 2. So I know that if I just make this negative a plus and this plus a minus, then that should clear things up for me. So I've got a 6x cubed and a negative 4x cubed. Adding them, there's more positives. There's 2 more. 2x cubed. So that is what I needed. So I have an x cubed plus 6 and an x cubed minus 4. So I'll zoom out for those 9 questions. Again, you can copy here, but it looks nicer on the answer key that I already did and handed in, just online or whatever. But you're more than welcome to look at this. It's going to take a lot of practice. And it's going to get a lot more difficult. So you really need to understand multiplying diagonals. I'm not going to be writing down the diagonals anymore. I just kind of did that for these first ones. And it seems like it just takes an incredible amount of time. This is guess and check. Sometimes I have to guess like 6 times. You should hopefully start to pick up some patterns though as you go along.